All right, this is a lecture on foundations. So, a place to start is with what a foundation is. And I think that this quote, even though it's a little bit off topic, um, kind of speaks to what we're headed towards. Good order is the foundation of all things. And that, I think, summarizes why having a decent understanding of what a foundation is, its function, and then the how to prepare a site and choose the proper types of footings and all these different things, which we're going to get into, is so important. Because if you have a crappy foundation for your house or your barn or outbuilding, things are going to fall apart rapidly. So here we go. So what's a foundation? A house needs a foundation to shoulder its considerable weight, provide a flat and level base for construction, and separate wood-based materials from contact with the ground. So we think of the ground as solid and immovable, and that's not true. Uh, it's dynamic. When the weather changes, more water gets put into it. When the winter comes, it freezes. It's constantly moving. And houses are weigh a considerable amount. Everyone's picked up a 2x4 or 2x4s at some point in their life, and we're like, "Wow, isn't a lot." But if you try to carry two or three or four of those, it gets pretty heavy pretty quick. And if you think about a house, that's what they're made of. And even though houses are largely just basically balloons of space, there's a there's a lot of weight there. And just think about you standing on a floor, and that weight has to go somewhere. So foundations bear the weight. They provide a base to build off of, and they're a way to anchor or interface with the ground, the overall structure. So when I say weight, we're going to be talking about this term called load bearing. And what load bearing means is that there's essentially weight above and it has to go to ground. Whenever you have weight, it has to end up at ground. And that's a good way to think about this. So, again, load bearing is weight, and it's the supporting member or beam or post that brings it to ground. And that's what the foundation primarily does. So you can see right here how you have the exterior walls, and then they have this thing called a footing, and that takes the weight all the way from the roof and brings it 2 stories down and then below ground, and allows it to be distributed. And you can see these arrows pushing up, the weight's pushing down, the soil's pushing up, and we have basically a net zero there. You don't have to necessarily use the exact foundation wall to support it. You can also use internal posts, and that's we'll get into talking about that. We did talk about that in our framing unit, talking about different types of loads, and um, how they're born and what they are. So, and you can see this roof all the way down. You can also have non-load bearing walls, even though this has weight to it. Um, it's not significant enough to make the floor deflect or bend or bow here. So it's the equivalent of you standing in the middle of the floor. It's there, but it really doesn't affect the overall structure. So you can also see we call these partition walls. These are generally our internal walls, like bedroom, etc. That doesn't mean that a wall that's inside of a structure is or is not load bearing. You have to see how the overall structure is designed, and there are different ways to tell that. Specifically, looking in the basement, and also the roof line and how those things come together. You're not expected to be able to determine that at this time, and it can be difficult. So we have our load goes into our foundation wall or our concrete pier or pillar, and then we have a footing, and that footing spreads the load out. So think about pressing on a table. If you press on a table with one finger, versus your hand, that changes the distribution of the load. Or those of you who probably have seen, who've been ice fishing, um, or have seen things with thin ice. One of the things you can do is if you step on thinner ice with your boots, or with your feet first, you're putting more load on a smaller footprint. Now, if you lay down on that same ice, you're spreading the load out over a larger surface area, and that's essentially what we're doing here. You have to remember, and we'll talk about this shortly, is different types of soil react differently. And by virtue of making sure that your footprint of your building is appropriate for the soil type or rock in some cases, you will adjust how your footing or your tie-in is. So with that, you want to make sure that you have a large enough footprint that you don't compact the soil underneath it to the point where your foundation shifts and sinks and settles. It's going to settle some, but the what you want to prevent is a large amount of settling, because what's going to happen is it's going to have ripple effects throughout the entire structure. You're going to have walls that are a half, a quarter, even as much as an inch or two out if your foundation settles too much over time. And you'll see that manifest in like cracking of tile, in the cracking of sheetrock joints and things like that, or there being differences in heights across a room. So that's it, and we'll talk about how walls and the floor and the footers all interact. You're going to see 3 or 4 different figures on this, the 3 types of foundations or the 4 types of foundations. The 3 primary ones are crawl space, slab, or excuse me, are perimeter, slab, and basement. So perimeter foundation will have what we call a crawl space under it. I was reading while I was talking about that. A slab is exactly what it sounds like. It's just a piece of concrete that has a building built upon it, and then a basement is exactly what it sounds like as well. It's another entire floor below your main structure. And let's see what those look like. So this one says 4 common foundations on the right, or the 3 we talked about. It depends on a couple things. First, where you are in the country. You can build a pier and beam piling foundation anywhere. However, then you need, if you're in Vermont or Alaska or any place that gets cold, you're going to have to insulate your floor a significant amount. The nice thing about having a basement is it acts as a warmer zone than if you did not have that, because you normally have your mechanical stuff down there. You can heat it, and also normally they're below grade, so you also get some of the heat retention in the soil, and the frost line doesn't normally go down more than 4 or 5 feet. And most basements are about 8 foot tall, so you actually aren't interacting with the cold outside in the same way. So that's basement versus pier and beam. Crawl space is like a basement, but it's not really useful. You can put stuff down there, but you're not going to go down there and have a laundry room or a weight room or storage. You'll have some storage a lot of times, but in crawl spaces, typically you're not going to see a slab. You're not going to see a concrete floor. It's going to be dirt. So it's just a perimeter foundation that allows you to support the house. Again, you're going to have to insulate the floor like our pier and beam, but you also do get some of the added benefits of the basement. There is a minor savings in crawl spaces versus basements, but in the long term, there are other things you have to take into consideration, like moisture and rodent and animal activity. So the crawl space is useful, but you might not be getting as much of a savings for a basement. It might also be where the water table is. So if you have a really high water table, you might be using the crawl space to mitigate water getting in below the house. So there are different reasons. And then slab, again, exactly what it sounds like. It's a small perimeter wall, footings, and then the structure built right on top of that. Okay, so soil and site. You choose a place to build a house. There are so many things you have to take into consideration from, and we'll talk about some of this later, about drainage of the land and where access to electricity and plumbing and things like that. But we're going to focus right here on what actually the house is going into or onto. And with that, sand, soil, rock, and gravel. So, man, there are so many different things that can go into this. And as I said, like, it depends on how the house is going to be built, the size of it, whether or not there's a basement or not. And these are just showing on the right hand side of the screen here. This is talking about basically different types of ways to tie in. This is not a great representation, but I thought it gave you kind of a general idea of how, like, a rock, when you have rock and you're putting a house on it, there's not a whole lot there. You're actually going to have to tie the house into the rock. Whereas sand or soil will dictate how deep you go with something. Soil and sand react differently to weight, compacting versus non-compacting, and also the general weight up against the foundation and things like that. If you really want to get into that, we can talk about it. But the takeaway is, depending on the material in the area, you're going to have to adjust how your foundation is. And well, let's just do this real quick. Sand types, you can do a footing, easy to construct and economical. Retaining structures must be used since sand cannot support themselves, so you have to be careful with that. Like, you can't make, you guys have all seen sand dunes, either from going to the beach or seeing a picture of the beach. They don't stay, they leave, they move. In Vermont, we have a lot of clay. We have a lot of that nice, very nice soil that goes on top of it. And you can actually break this down. You'll see that in a second. But the thing about it is that will pack together. It will grow grass, and it'll actually become either a benefit. Most of the time, will become a benefit to keeping erosion down. Sand's going to run away. Rock, as I said, water runs right off of it, so you don't have. But it also you're going to have to modify it to attach your home to it. I thought I had another slide in there, but that's okay. We'll move on to concrete. So concrete, that's what we make these out of. It doesn't matter if you're talking about piers. Well, that's actually the one instance where it's a little bit different, because you can use a wooden pier with some type of anchoring, which would generally be concrete. But it doesn't matter if you're using concrete piers, slab, poured perimeter wall with a crawl space, or a full basement with slab. You're going to use concrete. And a lot of people, they see Quickcrete, which is the stuff that comes in the bag, and they think that's what concrete is, or there's a concrete truck, and it's this mythical thing. Well, concretes can be really complicated. There's a ton of different types depending on what application you're going for. But with that, there are some basics. First off, how concrete is sold. It's not sold by the bag. It's not sold by the truck. It's sold by the yard. And 1 yard of concrete, and I'll show you this real quick. I'm going to go down one. 1 yard of concrete is 3 foot by 3 foot by 3 foot, or 27 cubic feet, or 1 yard cubed. That being said, you have to do a little math to figure out how, because a slab is not going to be 3 feet thick. If it is, the building is ginormous, and there are other things going on there. Most slabs are about 5.5 inches thick, roughly. And the reason for that is that a lot of us use 2x6s to form them. They'll vary depending on applications. If you're going to be putting a lot of heavy things on them, obviously you're going to go thicker, and the concrete you're going to use is going to be more suited for that. But generally, we're looking at about 5.5 inches to 6 inches thick. So 3 foot by 3 foot by 3 foot is 27 feet cubed, 1 cubic yard. To figure it out, you would take the thickness of the slab that you're making, the length, and the width, multiply those out in feet. So if it's 6 inches thick and it measures 25 foot by 55 foot, you do 0.5 feet, because 6 inches is a half a foot, by 25 by 55, and then you divide by 27, and that'll give you the total number of yards. You can only order full yards normally. I'm sure there's some odd situation that differs, but most of the time you're talking about a full yard. And how much is a yard? Like, I could hold a yardstick up if we were actually in class, but to kind of give you an idea, a cubic yard of concrete will give you around 9 wheelbarrows of concrete. So you guys have all picked up a wheelbarrow probably at some point. That's a wheelbarrow. That's 1/9 of a yard of concrete. So you're going to be moving 9 wheelbarrows if you're going from point A to point B. A typical rear discharge, they've moved mainly to front discharge trucks now. They're easier to control, and with that ease of control, because the driver can see where they're going, it changes the volume. But most rear discharge trucks hold 9 to 11 cubic yards. That's quite a bit, and the reason that they move around is they add water and they agitate it so that the concrete doesn't start drying and it gets to where it needs to go. So what does this look like monetarily? So the last time I bought concrete, which was summer 2019, it was about $130 a yard. So 9 wheelbarrows of concrete is $130. It goes up, it goes down. It depends on access to materials and actually how much the concrete plant is being used, because that's going to, like, if it's running nonstop, that's going to affect scarcity and a bunch of other stuff. And there are companies in this area like Carrera's that typically that sell concrete by the truckload. So a 24 foot by 24 foot garage is about $1,200 to pour that slab. So, and as I said, typical range $122. What this is saying. So I was right in that average range. Short load, which means essentially you have less than 3 yards. They'll up the price, or what they'll do is they'll keep the price the same, and that what will happen is, so think about this: you're pouring something like a short slab or a it's too much to mix by hand, but it's not enough to have a full load of concrete come, and you're like, I don't know what to do. So you order 2 or 3 yards. They're going to tack on an extra delivery fee because it's time, it's money to run the plant, it's materials. So that's just or they'll adjust the overall price of the concrete. So that's just how they go about it. So it's about concrete. This is why we want to do this right. So we talked about concrete, we talked about why you have a foundation, we talked about soil. This is how it all comes together. So if you have a poor soil, or you don't prep the site right, or you have bad concrete, all these different things can happen, and the end result is the house settles, the house shifts, the foundation and the structure start to fail. We have all seen structures like this, whether we really know it or not. What happens is things shift. As I said, if this is if you don't examine the soil or the area correctly from the beginning, and you have nice, good load-bearing soil here, and you miss the fact that right next to it there's some type of undermining, or the type of soil changes, and in construction it's missed. This stuff doesn't happen that frequently if you're using professional in each one of their areas. If somebody says they can do everything, they're lying. You need to specialize enough. Like a general contractor will still sub out and hire people who specialize in certain areas. But if somebody shows up with an excavator and they're going to say they're going to put the last piece of trim on, be skeptical. And it's not saying that there aren't people out there that can do end to end. Like for me, if I needed to, I can do end to end. I don't want to because I know there are things that I do better and I know more about. I'm always asking questions if it's something new. And that's an important takeaway is you can know a lot, but you need to be careful and make sure that you're taking as much into consideration. And even when you do that, you still see failures. The house is going to settle. There is no way to avoid that unless you have basically built it on an immovable mountain of rock and tied it in hundreds of feet down. It's going to move. It's going to shift. Houses move. You are going to eventually get some type of crack somewhere. That being said, it shouldn't happen on the second day you're there. I'm talking about 10, 15, 20 years down the road. Things are going to move, and that's why we have upkeep and need to maintain things. Okay, next slide. So this is, I think I'm going to change this in a future edition because this is jumping back and forth with soil and stuff and the foundation. But I think the reason I did this is because you need to understand the concrete and what foundations are, and then where to put them, and then how the soil then interacts with the foundation once it's poured. So it's kind of chicken or egg, and I think there are different ways to go about it. And this is the way I did it at the time, and I'm not super thrilled with it, but bear with me. So if you were to pour this foundation, you're not going to just leave a hole around. Like some of you might want a moat that's full of water and you have a little drawbridge. That's cool. But 99% of people are not going to leave their foundations exposed like that. And even if you did, that has a bunch of issues as well. When you put soil, clay, sand, or whatever combination of those things back against the foundation, there is an added pressure that affects how the foundation needs to be built. If you've ever taken the time, which is normally done on a vacation, and gotten buried in sand, like, you know, you're on the beach and so it's like, I want to bury you in sand. And you do that, it's heavy. And normally there's only a couple inches of sand on top of you. So think about sand versus clay, and any of you who have been in any of the fields in this area, especially you go a little farther north, know that they're mainly made of clay, and that clay is heavy when it gets wet. So when you have that, you need to adjust. Not only you can adjust two things: the thickness of the wall and the integrity or the PSI rating of the concrete. So wall 8 foot high with a 7 foot 4 inch 7 foot 4 inches of backfill, meaning that the wall sticks out of the ground, which it should. You'll need the wall will need to be 8 inches thick with sand, 10 inches thick with silt and clay. Wet silt or clay 12 inches, so if there's a lot of water in the area, or fat heavy clay, means that you need 12-inch thick walls, and it adjusts. And I just noticed that my G's on my engineering are in the wrong place in several of those, but that's fine. Engineer G required. But the point is that if you can see, like sand, that equivalent fluid pressure, which basically means the pressure that if you were to have a thing of water and you were pressing on it, 30 basically you have 30 pounds per cubic foot. Oh, there you go. 30 pounds per cubic foot. So basically, for every we've talked about a wheelbarrow load being a, excuse me, we've talked about cubic yards, now pounds per cubic foot. So you can, for every yard of material, which is 9 wheelbarrow loads, as we talked about, you have 30 pounds per cubic foot. Multiply that by 27. It gets heavy fast. So you need to make sure that your foundation is designed to deal with that. And this is what we're talking about here. These are a little bit blurry, but we're talking about how much it's pushing on the wall, and this is the chart. This is the different types of soil and what percentages they are, and this is how the pounds per cubic foot come out, and then this is what the actual application looks like. So you can see there's a little bit exposed above. You have your basement wall, you have your footer, you have your slab inside. And when I say slab, this is not a slab in terms of a slab on grade, which is the type of foundation. This is the internal slab of the basement, which gives you that finished portion. So we talked about footings briefly. Footings are important because they help distribute the load. They're the first thing you pour. You want to make sure that they are really dry and happy before you start putting anything else on them. And you can see here, there are different types of footings. There's the perimeter footing right here, and there are internal footings inside the perimeter of the foundation. Those will each have some type of column or load-bearing wall on top of them. And the reason we thicken that point is so the slab that gets poured over this tends to be thinner or more thin. And when they are more thin, what you need to do is you need to make sure that the weight on top of it doesn't punch through the slab. So you basically create a place underneath that's thicker, distributes the load, and also doesn't allow for the post to break through, because houses move. And over time, that repetitive motion will can break through the concrete if it's not thick enough. So this is kind of how the foundations are kind of like a big erector set. But they're, instead of having preformed pieces, most of the time there are preformed foundations, don't get me wrong. But with that, there are different parts to it. And as I said, we start with the footer, and once we have the footing done, we can pour our walls. Then we basically create, this is one type. We have a keyway where the wall actually will be poured into this little channel, or set into if this is a precast. We really haven't talked about that. Well, here it is. Or concrete masonry units, CMUs. Those are those precast pieces, meaning that instead of being poured on site, they're made elsewhere and they're brought in. And that's potentially what this is. And then our concrete slab is poured last. Sometimes you'll wait until the building's on top before you pour this, depending on how it's set up. While we're doing that, there are a couple things. There are the prep steps. These are what we call forms. This is called rebar. You guys probably have heard of it talked about in some other context or in terms of concrete, but rebar is an internal structure. It allows for the concrete to hold on to something, and it adds a lot of strength to it. It also, in this case right here, here's our footing. It helps tie our vertical wall into our footing. Because you really couldn't pour the footing and then the vertical wall at the same time, because it would just push out. You'd have to have this completely contained, and then you'd have a bunch of unnecessary pressure and you'd have to overbuild it. You can see these through here. Then you have also ways that you tie your forms together so they don't fall apart. These cross ties also, depending on the style, will interface with the rebar, and it's just, again, giving a structure for the concrete to hold on to. Makes it much stronger. So slabs, as I said, poured after the walls. You can do a bunch of different things with slabs. Again, their thickness will depend on what they're going to be used for. Is this the same? No, I thought for a second this was the same house. I was like, wow. Well, it actually might be. Huh. Didn't notice that. This actually might be the same house because look right here. Yeah, it is. Anyway, right here, this orange stuff, that's going to be for radiant floor heating, and that we insulate underneath the slab a lot of times. This helps with moisture. Also, you have to be careful, especially in certain areas. There are naturally occurring radioactive materials that can seep through. Also, other chemicals can seep through, naturally occurring. But that's one thing you have to be aware of. So you want some type of vapor barrier, and we'll insulate as well. Just it helps everything overall. This is radiant floor heating. We're going to pipe hot water or some type of liquid through it. You can also have a radiant floor radiant floor heating that is electric, depending on what you're trying to do and how you're powering it. You also see the plumbing comes through. That's because we're keeping the plumbing below whatever the frost line is, which I believe, I don't know if we've talked about that. We talked about insulation, and we talked about the frost line briefly. So you have the frost line. All your plumbing's below the frost line. It goes either back out to a main sewage system or a septic system. So you see right here, these guys start putting the concrete in, and then as time goes on, because the way concrete actually hardens is the water goes away. It either it evaporates or leaches into the ground. The water most of the time will come up. This gets a nice creamy finish. It actually looks almost like a gray milk. And what we do is we use this thing called a float. And that float allows us to put that nice, smooth finish on it. We'll also use this thing called a screed board, and that screed board is basically a piece of wood or something similar, and that helps us level everything out based on what we're doing. And you can see here, this is moisture, like everything moves. So other than the wall and the footing, that slab, we give a joint for it to move a little bit, and also prevent moisture, because otherwise it's going to crack. And this is how it all goes together. And you can have different ways you do this. You can have there's more than just this, but this is the two big ways. You can pour the basement floor right on the slab, or excuse me, right on the basement floor pad or the slab right on the footer, or you can put some type of insulating layer below it. Take into consideration, you see how all this right here, and we'll talk about this briefly later, is everything goes away from it. You're going to have this all exposed. You could, this gravel, so sand drains well. Clay doesn't, depending on what kind of aggregates you have. Everyone, if you've been to, I don't know if Rutland's Fair has it, but if you've been to the Alaskan County Fair, you'll notice that a lot of the pathways are packed stone. And if it rains, the water doesn't really go through it so well. But sand is very porous, and the water drains right through it. So when you have stuff like this, you can layer your different aggregates or materials so that the water goes through, and you can see this pipe right here. This is for drainage. You also notice how this is all sloped away, even down low. And the reason for that is if this were to go the other way and this does not drain, and I have a picture of this later, water will pool right next to the foundation. And even if it's not directly leaking through, it'll create a damp foundation, a damp basement. So this is an example of a slab on grade using a little frost wall with a footer. That being same thing, floating slab here. You can have the footer down below, insulation, some type of gravel drainage to help keep the water out. I don't know if I have this later. I'm forgetting right now. But one of the other things about slabs, I think I have a slide later that'll show you. But I want to mention this thing we call them floating or Alaskan slabs. They're just the slab. There's no footer. The whole building moves and pitches. My shop is like this, and it's moved probably 2 inches in 10 years in some places. We don't have to always pour the foundation. Everyone around here has seen houses like this. The funny thing is, a lot of the houses, especially close to Lake Champlain, that look like this, came from Fort Ticonderoga. A lot of people don't realize that Fort Ty pretty much was just a pile of abandoned rocks about 150 years ago. It was rebuilt, and a lot of the houses in the area, because the rocks had already been mined and refined and used to build the fort, were taken after the fort was no longer used and used to build houses like this. I actually don't know where this house is, but I'm just using it as an example. We can also have masonry type foundations, brick, or these. Well, this uses a little bit of both. We probably have a poured footer down below. You can see these poured footers here, so we're still utilizing concrete in a very similar way, but this gives a different aesthetic view, and there are different reasons you'd select this um, for your wall, and it also has a design aesthetic to it. It gives a certain look. So masonry, these are cinder blocks. So if you look over here, rubble, brick, poured, concrete block are our major ones. This is an interesting newer development. It looks very much like our other forms that we talked about. You've got your tie-in, you've got rebar, you've got your footer, but this is a form that doesn't move. These are a foam form, and they provide insulation on the inside and the outside. It's also, I would most likely, I don't know, I can't speak because I don't know this brand. Generally, they also act as a vapor barrier, which means preventing water and other things, off-gassing and things like that from getting into the foundation. The other nice thing is they all snap together. You still have to make sure they're level and square and plumb, but they're also a good example of a modern solution that has additional benefits and, depending on how it is, costs. Oh, here's our Alaskan or floating slab. So you thicken the edge. I knew I had this in here. I just, for some reason, sometimes I take stuff out because I go too deep into stuff. So you have your main slab poured. You can insulate. The other option is just putting plastic down as a vapor barrier. You normally thicken the edge, and it just sits. The whole thing moves as one unit. You use rebar or mesh throughout the whole thing, and you can see right here we're using anchors to grab our 2x4s or 2x6 wall plates. You're going to generally use some type of we'll use some type of sill seal, which is basically a gasketing to keep moisture out. The other thing is you'll use pressure treated right here because there's going to be moisture. It doesn't matter how good you are, there's going to be a little bit of moisture. And that helps prevent rotting. This, I don't expect you to fully get this. This is a floor plan for a house, specifically with all the detail for the foundation pour. Same thing. This one's way too blurry, but you can see keyway, slab, these different styles. This obviously it's blurry, but I wanted you guys to get the impression. This basement style will be for the main house. This slab style with a full wall, with a full frost wall and footer, will be generally for the garage. We're going to go down. We want this to be stable, so we're going to go down below frost and do everything right. There's not necessarily, it doesn't look like there's going to be anything below this. These breaks right here are just to help with the view. They're actually a taller wall. There's just nothing there that you need to know about. Okay, it's a 9-foot wall. The stuff you need to know is at the top and at the bottom. Okay, does water matter when you build a foundation? I bet you can answer this one. Yes. Depending on what you're doing, you're going to have points of entry below ground into your foundation. Some of them will be above ground, but could have water get through them like a window, if not drained right. There could be water that's below ground. We have this thing called the water table. It is exactly what it sounds like. It's where the water sits in the ground. And that water table raises and lowers depending on the time of year, how wet it's been, a bunch of different stuff. With that said, also your foundation itself can leak just by having cracks. So this is a block foundation. If that cracks right there, that mortar, it's a great place for water to come in. Interfacing between the footer and the foundation, interfacing between the slab, the foundation wall, and the footer. So that's one of the other reasons that we want proper gasketing and make sure that we allow it to move, but also seal water out. A lot of this has to not only do with what's below the ground, but how you situate the house. Sometimes you don't have this nice, oh, it's at the top and there's no hill behind it. Sometimes you have this hill. Well, you can take care of that. You dig a trench, even though it might still be in line, you create a low point coming off the hill, and you put pipe and permeable stone in this, and you take the water away. It costs money, but that doesn't mean that you have to be subject to random site issues. You can make the site work for you. There are some places it just will never work, or it will be so wet that you'll have a basement full of water, and there are ways to deal with that. So let's talk about that. So if it is wet, or even if it's not necessarily super wet, it's always good to take precautions against moisture, because the last thing you want to do is store something in your basement, use it once a year, and every year you come back and it's rotten, or you have a smell in your basement. A lot of that comes from moisture. So you can waterproof the entire foundation. This is one way to do it. Make sure the grade is done well. So everything like this right here flows away, flows away. I have what we call a perimeter drain, which is piping, which will daylight or go. When I say daylight, that means, we'll go back to here. Daylight means if I had a piece of pipe that ran here, it sloped this way, and it actually opens up at the end and allows water to flow out of it so that it sees daylight. It's underground and it sees daylight. So that's what this is. It's normally perforated pipe, which means it has holes drilled in it. So one side has holes drilled in it, and then the other side has doesn't have holes drilled in. So the water drains into it and the water can flow out. And depending on what we're doing, we might have our own septic system. We might just have water that flows out into a field, or additional swale, which is what this is. It's just basically a ditch, or it might go into a sewer. A lot of sewers will have, they should, a sanitary drain, which is where black water goes, which is waste, and then storm sewer water. Okay, this is that picture I promised from earlier. Impervious soil, clay, slope back towards the house. So this all looks good, looks great. Water drains through that, hangs out right by the foundation. The only way to fix this, dig it down, find where it is. If I were fixing this, I'd take off my soil layers. I would probably recognize when I know I'd recognize. I'd recognize where this transition happens. I would dig all the way down to the footer. See how it has a perimeter drain? This perimeter drain is not getting much water. I dig back probably about 3 or 4 feet, at least to where the spout is, or change how the spout goes. I dig back 3 or 4 feet, make sure that this gets cut off and sloped here, and then what I would do is fill this whole void with some type of permeable rock and geotextile to prevent settling. and we haven't talked about geotextile. It's basically it's ground fabric. What it does is the soil doesn't wash through it. It keeps the soil from settling as much, but also what it does is allows water to still pass through. It also keeps the soil from getting into your pipe. So I basically put some type of permeable stone here so our water flowing out could get to that perimeter drainage, and then I'd cut all this back and then refill it and slope everything away from the house properly. That's how I'd fix that. So as you said, this is sloped too far back, so it's running into this, and you can see how this is all wet. The other option is if you live in a really wet place or you have an older house that always has a wet basement, you can put a sump pump in. So what a sump pump does is, this is one that's probably put in right from the beginning. The sump pump, you put a bunch of pipe in it, and it all goes to a low point that's well below the grade of slab, the grade of the slab, and that pump actually pumps the water up and out and somewhere away from the house, depending on what it is. And that sump pump basically only kicks on if the water gets to a certain level. So it's not constantly running. If it's constantly running, you got bigger problems than just a little bit of extra groundwater when it rains. So this is to prevent water from getting up to that junction right here between the slab and the footer. So you go down below, it has a float, it's plugged in. When that float raises up, it turns the pump on and the water is expelled. And that's it. That is that's why we do foundations. That's how foundations work. That's considerations of soil and water. We didn't dive too deep into the soil, just knowing that it is a consideration because there's so much that goes into soil engineering and things like that. So hope this was informative, and talk to you next time.